All right. Um, I hope I'm audible. So, good morning, everybody. This is day two of doing gate problems. And as today we have completed a paper that is a very great achievement, if I might say. And we have also done some, what do you call, some problems of, wait, some problems of 2025 set 2 aptitude. We have done the 10 problems, and there was one problem that I did not understand in aptitude. That's related to trigonometry, so there is no wonder. Right, or is this general aptitude? I have understood it, and I also left thinking about it, so now I should be able to do it. What do you say? Yeah, this one. A square is given and a triangle is given. So how should you think about think when you are solving questions like this? Good morning, everybody. Welcome to stream. That checks out. Yep, that checks out. Let's open OneNote. Right, and let's continue. So we will take a new sheet today. 2025. It says set 2. How about that? Let's put some rule lines, grid lines. They work out. Yeah, that's good. And let's change the palette, shall we? Let's change to, a bit of light colors. What? No, that's not what I meant. Okay. One of a little yellow. Yeah, seems good. So, what we were given? We were given a square of 2 centimeters, and we were given a rectangle. So, my question to you is something like this. You are supposed to find the area of this rectangle over here. How are you going to find it out? We only know two formulas. Actually, one formula in this relevant. Area of rectangle is equals to, what is the area of rectangle? L into B. That is a basic formula. So you are supposed to know the length of this one and the length of this one as well. How are you going to know that? Well, you can see some triangles forming here, and you know some properties about squares. Square, 90 degrees each angle. Rectangle is 90 degrees each angle. So if you take this one, let me just take a screenshot of this, and don't expect me to speak in the same way after like half an hour or 40 minutes. The energy is going to drop very significantly. So this and this are equal. If you think of this as theta, then this part will be 90 minus theta. And if you, and since both of these two, right, and if you say this angle and this angle are same, so this is 90 minus theta, this is theta as well. So you know this is 2, and you need this one. Right, what is sine? Opposite by hypotenuse. We don't need this one. As you can see, this is 90 degrees. So this is going to be hypotenuse. So you don't know this one. So you are supposed to find the length of hypotenuse in this triangle. Triangle PQL. If you see cos theta, right, that is 2 by PL. So PL is equals to 2 by cos theta. You got that one. This is 2 by cos theta. Similarly, you need this one. So where can you find this one? This length. Which triangle is covering this length? Maybe this triangle. Can you do anything with this triangle? Can you do anything with this triangle? You know this is 90 degrees. I have only look at that this part of the solution. That's I don't remember. Right. Oh, what is the other triangle that you are supposed to consider? This is 90 degrees, so this is a right angle triangle. And this is theta. So, yeah, wait. You know the length of this one, right? You know the length of this one. And you just need the length of this one. And this is what? Alright. Cos theta is equals to adjacent by hypotenuse, absolutely. That is Pn by, what is hypotenuse? 2. So, Pn is equals to 2 cos theta. PL into Pn is the area that you need. So 2 by cos theta times 2 cos theta. Cos theta is going to cancel out and that is 4. You got the answer. Congratulations. P N S Q L R M. So take triangle PQL and triangle PNS. Get values of what do you need? PL and PN. Angle PQL is equals to angle this one, right? No, what I meant is angle QPL actually, sorry. Angle QPL is equals to angle SPN is equals to theta. Alright, let's do this. Theta 90 minus theta. Alright, in that way, you get that as theta property. You will just get that. Very good with that. So, we will now come to the subjective questions. The order doesn't matter. Two grammars. G1, G1 is if E then S, if E then S, else S. What? E B. Yes, if E then S. M if E then S else. Right. What? Where if then else or terminals. Okay, I don't have any prerequisites required for this question. Compiler design. Is it a question from compiler design? Okay, I don't know. I do not have any prerequisites required for this question, so kindly please help me out and explain every term. That checks out. You don't need prerequisites or everything. Okay, grammar. I don't know. So context for a grammar, a set of production rules where each rule replaces a single non-terminal with a string of terminals. Or okay, I don't know. At least one string in the language has two different parses. You need to come from what grammar is. I have it. A grammar is a set of rules that describe a valid sentence in language. That's good. That's good. Computer science uses grammars to describe programming languages or structured inputs. Alphabet, just like letters in English, may have symbols. Okay. Terminals. These are actual words or tokens that appear in the final. Uh, no. Alphabet is not if else, right? I don't know. Placeholders as for statement, A for expression, M for middle statement. They don't appear in the final sentence, they expand into terminals or non-terminals. Rules that say how non-terminals can be replaced. If E statement is can be if E then S. If E then S, else or just yeah. Okay. After I have a sentence using grammar, you want to start with S. Apply the rule. If E then S, replace E with B. If B then S, replace S with A. If B then A. Okay, start with yes. Got it. Apply rule. Yes, if E then S, that is the first part. Replace E with B. Then we have B then S. Okay. Replace S to A. If B. Okay. If B then A. These are just placeholders, and you can put anything in there. And grammar is ambiguous. If same sentence can be generated in two different ways. If B, then if B, then A. If B, then if B, then A, else A. Okay. If B, if B, it's like indentation problem. Since both are possible, the grammar is ambiguous. Left to right reading of input, L1. Leftmost derivation example, leftmost non-terminal first. Only one token located to decide which rule apply. If two rules start the same way, then parser cannot decide. Back to your question, alright, grammar is even dangling else. Dangling else problem, it is not ambiguous. If E, then S. Middle statement, if E, then M. Else S. A grammar is not LL1 if it is ambiguous grammar, it has left recursive grammar. So if E, then so let me get something clear. Check if we are on the right track or not. Ambiguous is like you can't exactly determine if the rules are simple. Else can belong to both if E then S inside one or then S outside one. So that's dangling else. Kind of like dangling pointer. And what is LL1? There are like 3 rules written for LL1. What are the rules written for LL1? MB use grammar, left recursive, and common prefixes. What are those? My eyes are paining for some reason. Yeah, grammar in which at least one string can be parsed in 2 different ways. Else is could attach to an array or outright. That's a dang else problem. Uncertain statement LL1 means scan input left to right, build leftmost derivation, example leftmost not terminal first. Is one token of locator as that which will apply. You cannot build a unique parse tree, example dangling else. A normal, a non-terminal call it. Lack of left factoring. S. Okay, good. That is making sense. So, yes, compiler design is an interesting subject. Okay, so problem with dangling else. I don't think this blue pen is making much of impact over here, so let's try another pen, shall we? We got this shade. Yep, let's do this. Problem regarding dangling else. If E, then S. If E, then S, else S, A. This might not be perfect. Might not be perfect technically. idea, but consider this. If E S if E then S else S. Option A. Option B. People who work with Python indentation can relate. So it is ambiguous. Okay, I guess that is enough. Let's move on to the next question. Whoa, 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 whoa. Whoa, whoa, whoa. So a directed graph is given. This is algorithms question. Our subject, our question. Let's do this. Oh, now this makes me remember in 2024, do we have any questions regarding algorithms? I think only data structures, right? 22 minutes. Very good, very good. Uh, it is giving bigger lines. I don't know. I don't know. Anyways, directed graph. All right. There are 100 vertices and edges. J minus I is less than or equal to 2. Okay, suppose edges in the list is in decreasing order of vertex number and depth first series square from that vertex 0. The number of vertices will be discovered after vertex 50 is. Okay. So let's try to simulate the graph. 0, 1, 2. Alright. It's j minus I. If you think it is j minus I is less than or equal to 2. That's good. J minus I. Is it mod j minus I? No, it is not mod j minus I. Okay, 0 comma 1. If you take the pair, it is good. And if you take the pair as 1 comma 0, okay, that is directed graph. So 3 will not be connected to 1 at any cost. 3 will be connected to 2 and 4 will be connected to 3 and 2. Something like this, you will get a graph. So adjacent list of each vertex, decreasing order of the vertex number. So if you do that, 4 is connected to 3 and 2, that's it, right? Something like that. The number of vertices that will be discovered after vertex 50. How are you going to do this? Depth first search, alright. So if you start from 0, it will go to 1, 3. There is no need of backtracking. Yeah, for every edge, I plus 1 and I plus 2 vertex. Also got an answer. Zero is connected to 2 and 1. 1 is connected to, right. So my doubt is something like this. For all I come and say, this is the rule, right? E is equals to I comma j. 0 is less than j minus I. Less than or equal to 2 for all I comma j belonging to V. So it was never told that you can take I comma j as 1 comma 2 and 2 comma 1 also works. So it will be directed on both edges. If you say 1, 0, 2, I don't know, dude. So 1, 0, 1, 2, 1, 3. I read here, right? 0, But algorithmic context indices of an array. Hmm. Okay. J is equal to e plus 1 or j is equal to I plus 2 decreasing order of vertex number means for any vertex plus 1 I plus 2 since the list is in decreasing order I plus 2 will always be explored before I plus 1. Got it. Alright, so implicit I is less than or equal to j. So yeah, if you take 0 comma 1 is a pair, 0 comma 2 is a pair, but 0 comma 3 is not a pair. So 0 will be connected to 2 comma 1. Similarly, 1 will be connected to 3 comma 2. 2 will be connected to 4 comma 3, etc. As we know, DFS, we just know DFS. DFS explores as deep as possible before backtracking. 0 to 2, it will visit 2, it won't visit 1. Now it is at 2, now 4, 6, until 100. But we need number of vertices. It visit after 50. So 0, 2, 4, 50. That's 26 vertices. Total vertices is equals to 1 not 1. 1 to 100 plus 0. Make sense? Yeah, makes sense. So 1 not 1 minus 26. That will be 575. That made a lot of sense. Okay. Oh, it went somewhere else, man. A, B, C, alphabet set. X belongs to sigma star and A belongs to regular languages. Regular, it is just strings of it. Right. We we need to know some more theory for this one. Admin. When did Sar change his name? I don't know. Arjun, है ना? Which one or more of the following options define your language? The question defines the few languages or the alphabet. Okay. Regular expression or finite automation. Unbounding conditions or comparison. Okay, good. Here's a stack. Contextual language. The number of ways in the strings. The number of ways in the string leaves a reminder to is regular, it's regex. Okay. A comma B star. Yeah, the star is supposed to come here. Formal definitions or languages are regular. Okay. I thought we got to do a lot of with this question, but I do not have anything to do with it. Reminders are finite. Finite set of states. It can store arbitrary numbers. It cannot store arbitrary numbers. Alright, 2 mod 7. DFA has 7 states representing the remainder. Okay. Different. Alright, people. I will come back in a. Alright, we are back. So let's get this clear. This means counting function. Denote the number of occurrences here. That means counting function. Let's see. So what does this mean? A power m, b power n. Any a's and b's. Finite. You eliminate if you have something other than a and b. A comma b closure intersection a comma m b comma n c comma m minus n. So it should be a if it is a power 5, b power 3, then c power 2. So keep track of both a, b occurrences, not finite, I don't think it is not even context free if we were to say that. Let's see. Okay. Oh, the second string allows that forces m is equals to n. Okay, okay. It is context free. How about A, B, C star? Well, because you need M and N to be tracked. Yeah, it is good at reasoning. PDA push down automation has only one stack. It cannot be implemented by one stack. So we got it. Well, we are not discussing about context free. It is not finite. That's for sure. And if you look at all possible combinations of A and B and 2 mod 7, 3 mod 9. So 7 states implemented, 8 states implemented. It is finite. Comparing to an absolute quantity. Even if the number is 100k, the answer will be between 0 and 6 or 8. And if you look at this 2 mod, this part is not regular. Relative comparison. D has a relative comparison. So, no RL. We understood, man. We understood. Good to see. I did 3 questions, that's it. 3 questions in 49 minutes. Oh my god. Transactions. 2 transactions were given, which are the schedules are conflict serializable. Wow. Okay, let's see. R1 R1x W2y. Alright, W2x. W1y, W2y, R1x, 1x, sorry, W1. Commit, commit, conflict serializable. So, you are the transaction, the No, I know what conflict serializability is. Yeah, this read and read are having A is not conflict serializable. Not conflict serializable. And W2x R1x W2y W1y commit commit W1x commit. We just wrote commit. We read x. We wrote y. The written value. A and B are not. I need to check if my graph option is precedence graph. Yeah. Only schedule 2 is not conflict serializable. W2 anything W1y. Yeah, but this one got committed before, so that doesn't work. W2y W1y. Okay. Learn precedence graph. Guess we need to learn how to draw the precedence graph. Transactions and items. R1x W2x W1y W2y R1x Right. So let's try to draw something. T1, T2. Read X is yep, writing and writing X. Is it writing X too? Yeah, it is writing X too. No, not conflict serializable. 1, 2, 3, 4, 5, 6, 7, 8, something like that. So is it writing Y? Yeah. Okay, it is. Is it writing X? Is it writing X? It is, but it got committed before. So, no, you don't draw an edge. It is reading X. Is it writing X? No, it is not. It is writing Y. W2 to W1 is an edge. So conflict serializable. It is conflict serializable. Can you draw this directly from the question over here? Let me see. So R1x, what do we need? W2x, W2x. We got this. W1y. What do we need? W2y. So this is T1 to T2, and again this is T1 to T2. So W2x, we need W1x. W1x, this is T2 to T1. Everything happened before commit, so yeah, that's messed up. Not not conflict serializable too. Okay, and W2x, what do we need? W1x. W1x, there is no W1x. We committed before. So there is read of x, right, R1x. So we need W2x. No W2x. W1y. W2y. We need W1x. We don't have that. But T2 got committed, right? R1 of x. W2 of y.